Hey guys, welcome back to K-Math. We're going to be talking about some circle problems. We're going to be doing numbers 2 and 3 here on this packet. So let's do 2. Circumscribed polygon ABCD. Given these line coordinates, line segments, the measurements. So a circumscribed polygon is going to be in where a polygon is circumscribed on the outside of the circle. So there should be one tangent point on each of these sides. And knowing that we have these measurements and that this is a circumscribed polygon, you couldn't do this with a regular polygon. You would have to have a circle in here. You can use a theorem that each external point will have two similar tangents, or two similar tangents will be congruent to one single external point. So this will be congruent, this will be congruent, this will be congruent, this will be congruent. Okay, knowing that, let me make this a little smaller actually. Knowing that, and we have these measurements, we have to find length AD. And if we put this as x, we can say automatically that this is also x, because remember they're congruent. And going down the line, AB equals 15. And you already have an x value here, so this would have to be 15 minus x, because you gotta take away how much x is from here, and then that could be the length, so that adds up to 15. Then you can break that down as well using the same theorem, and BC you apply the same thoughts. So it's going to be 23, and you need to find the substitute of this after using this to get 23. And to do that, there's no way to predict what x will be, so you can't plug in a random number. So you're going to have to cancel it out. So you would make this 8 plus x. So these cancels out and it equals to 23. Bring that over here and do the same thing here. You need to get 35, cancel out the x. 27 plus x. Then bring that over here. So basically you're just using one theorem and you're bringing these all over here. And while doing that, you have to make sure that each line adds up to its original amount. So if you check each line, it'll equal up to each amount, because either they cancel out. So now we have to find the value of this line as we're asked in this question. So we can just plus this and we can get the measurement 27 plus x minus, 27. Oh god, I'm tripping, my bad. This is supposed to be 27 minus x. Because remember, canceling. That's not bad. So it's going to be 27 minus x plus x. And these cancels out, and your final value will be 27. So AD here will equal to 27. One core thing to remember about this problem is that, well, not a core thing, but if you're going to find the value of x for one of these sides, you want to start from the side where it's the shortest and then end on the highest. Because if you go from the highest side, like you put x here and you solve this way, then you're going to turn out with some negative numbers, but you'll get the same correct answer, but it's just a little harder to work with, which is something noticeable to point out. So let's do number 3 here now. PA, PB, and PC are tangents to Q. Let's erase this a bit. Or tangents to Q, and circle R from external point P. Okay, noting that these are tangents, that means there's one point in contact as in each of these circles. And from this common external point, so you can deduct that some of these lines will be congruent to each other. So A says if PA is equal to 15, this line here is equal to 15, what is PC? Using the same theorem before, one external point has two tangents, or two tangents have one external point and they're both congruent. You can say that these on the same circle are congruent, So on this circle, these two lines will be congruent. Then when you look at this circle, these two lines will also be congruent. So therefore, you can say that this line is equal to 15 for this circle. Then this circle, you can transfer that 15 over here using that same theorem. Then, for this answer, find PC. Using that theorem, we could find that PC is equal to 15. Let's do B. If PA equal to 18 and AR is equal to 8. So PA is equal to 18. AR here, this radius is equal to 8. Okay, so what are we looking for here? We define PS, which is this line right here. And no, we can't use the same theorem from before. This is not a tangent, as it'll run through more than 2 times. A tangent can only run through once. So we can't use the same formula. However, we do have the radius, and we know that this is also radius, so this has to be 8 from here to here. And this line has to be 18. So using that basic knowledge, we can apply the polygon theorem. We know that this is a right angle using the theorem that the radius will form a right angle against the tangent wherever it intersects. So let's set up that polygon theorem. So it's going to be 8 squared plus 18 squared is equal to, let's make that x squared. We're going to plug in these numbers. 8 squared plus 18 squared, and you get 388 equals to x squared. Square root that, square root this, you're going to get square root of 388. You can take out a 4 from there, so it'll be 297. Okay, so 297, if you look back at the problem, 297 will be this entire hypotenuse. But then you realize you're only looking for this small section, and that, so you have to do one more step. And that step is easy because you know that this part will be 8, and if you subtract this whole line by 8, you'll get what you're looking for. So that being said, that'll be 297 minus 8. And that will be your final solution for finding PS. Alrighty, do number C now. Wow, this is laggy. Okay, if measure of RPQ is equal to 38, let's erase this. RPQ, this line right here, this is equal to 38. Then what is APC? APC would be this entire angle here. So here we just got to use some our common theorems. And when we look at it, we know that APR and SPB, the angle is congruent, because this is a line going through the center, and that bisects it, so the angles will be congruent. So I can write, let's just write this here to make it a little clearer. Ooh, okay. So it's going to be angle AP to S is congruent to angle SPB. We can do the same thing for this circle using the same theorem that this bisects and angles be congruent. That's going to be angle BPQ not even congruent, sorry, just equal. So just equal to QPC. So after you've written these two things out, now look back at what we're given. The RPQ equal to 38. We can do a little bit of substitution here. We know that RPQ is SPB and BPQ combined. So SPB here and BPQ combined. So if you just cancel those out using these, this will be 38. So these will be equal to 38, and they're equal to these other values that you can deduct using transitive property, that APS plus QPC will also equal 38. Then you simply just combine these together to get the whole angle, and you get 76. Because they're both to the same value, they both are the same value, so it's times 2 and you get 76. So the entire angle here shown will be 76, and that's the answer for 3C. So guys, if you enjoyed this video, make sure to slash the like button. Make sure to hit that like button and subscribe to the channel. Thank you for watching.